In the last video, we saw how we would perform manual memory management. We have to always deallocate the memory that we have allocated on the heap. This is still the way memory is managed in languages like C and older versions of C++. In this example, it is simple enough, but this approach gets harder and more error-prone in larger code bases. This is not an issue in higher level languages like JavaScript, Java, or Go, where the language comes with a heavy runtime and a garbage collector that takes care of the unused memory. But a heavy runtime is unfortunately not an option for systems languages, so the solution that modern C++ and Rust use is called smart pointers. So a smart pointer is just a wrapper around a row pointer, adding additional capabilities to it. There are many types of smart pointers, but the most common one will make sure to free the memory it points to when the pointer goes out of scope. So let's look at an example for this. This is the code from our previous example for the heap. The only change that we have is that here, instead of just allocating memory on the heap, we create a new smart pointer, passing it the value that we want to put on the heap. So let's start execution from here, and we can see that again it will go ahead, allocate some memory for us. But then on the stack, we don't just store the raw integer that is the address to that memory location, but we wrap that address in a smart pointer. So then when the stack frame for the function goes out of scope and the smart pointer is destroyed, it will make sure to go ahead and deallocate the memory it was pointing to. So now we no longer have a memory leak. We don't have to think about deallocating memory here. We can just continue executing our code and it will work just fine.